So welcome to our Salty Science series. Today is November 12th and it is 6 p.m. and we are really thinking about this beginning spot of thinking about Great Salt Lake in a time of change, and really water and humans are those issues that we're going to concentrate on tonight. In 1984, I was just a young person, and that's when I first met Great Salt Lake. And really, I didn't go out there to meet Great Salt Lake. I was just a young person, and my dad took us out to see I-80. He took us to the south end of this lake to check out I-80 and see how it was going to be swallowed up by Great Salt Lake during those really high water years in the mid-80s. And I didn't really go out to the lake again until I was in college. It was probably in 1994, 1995 that I went out there, I think with some friends, and really didn't think much about it until I graduated from Utah State. I know there's a few people around here from Utah State University. Dr. Trentelman, Dr. Dave Parrott is here. Dr. Dave Parrott is the new assistant director of Great Salt Lake Institute. He's a Utah State person. Of course, Dr. Sarah Null is also from Utah State and is teaching at Utah State right now. And as a college student, I was able to get a job working on the lake. And so I started working out there and accidentally got stuck working at Great Salt Lake for my entire career. And over that time period, you know, if we watch this time lapse of the lake levels, of the surface elevation of Great Salt Lake, we can see how much it's changed, how dynamic it is, not just in a year, but over these years from 1983 to 2020 that I've been watching the lake. And I think that my view of the lake is very much characterized by this change that I've seen. And not just in the lake levels or where the shorelines are, but I've seen all of these amazing researchers and students come onto the scene also. And let's see if I can make my slides work. And after I was at Utah State University, I've had this really cool career where I've been able to see the lake through the eyes of both brine shrimp harvesters from academia, and also from the state of Utah that manages the land and the wildlife of Great Salt Lake. About 12 years ago, some faculty from Westminster College, including Dr. Bonnie Baxter, that you'll hear from later, created Great Salt Lake Institute at Westminster College. And right now, you know, our mission is to connect people to the lake through research and education. I have to say, I really love my job. It's like the coolest thing that I could ever imagine. And it's led to these really interesting things like creating this book. You know, Bonnie had this harebrained scheme in June of 2018. I think she tried to sell it to me as, hey, don't worry, Jaimi, this will be the easiest thing. Everybody else will write the chapters, and all we have to do is just, you know, kind of like manage and organize. And it turns out that we shouldn't listen to Dr. Bonnie Baxter when it comes to writing books and compiling information, but it's super rewarding. And so from June of 2018 until August of 2020, we have been, from like that first inception when our biology book was born until we got this book in hand, has been kind of this really awesome journey. The student holding this book is actually one of the chapter authors. Kara Kornhauser will be talking to us about her research on the tar seeps in later webinar. The cool thing is from right in the very first ideas, we were really talking about the biology of Great Salt Lake. Both Bonnie and I are biologists, and we hang out with a lot of really cool biologists and upcoming biologists that are still students now. And we wanted it to focus on change because we're really, you know, in my career have seen so much change at Great Salt Lake, and we wanted to put that into perspective and have this book that's really looking towards the future of Great Salt Lake, with more people and more water diversions, and then climate change that will compound that. If you really want to buy one of these books, I have to say, Bonnie and I don't make money off of this book. We got paid a little bit of money to do the organizing. So if you're really interested in getting a book, buy it at the King's English. The King's English has an online portal, and you can order that, and they'll order the book in for you. And so, you know, as Bonnie and I were really starting to think about things, the first, you know, we thought about were these issues of water development and water use at Great Salt Lake. And then in climate change, what happens with climate change? And of course, people have something to do with that. And so we asked different people, experts, to write these chapters. Today, our webinar is going to focus on water and humans at Great Salt Lake, but there's 16 chapters. There's structures that are called microbialites. There's lots of complexity in the microbes, even that live at salt saturation, that live in so much salt it falls out of the water. Of course, we'll talk about the charismatic macroinvertebrates and the phytoplankton, the brine shrimp. Great Salt Lake, you know, hosts 10 million birds and lots of species that entire populations rely on them. And so we will talk about the pelagic birds, shorebirds, and I never shut up about American white pelicans, right? Everybody knows this about me. So we'll talk about pelicans. There's no amphibians on Antelope Island, but we will talk about reptiles. And of course, plants. Dr. Dave Parrott, who is the Assistant Director of Great Salt Lake Institute, will talk about shoreline plants. Dr. Karin Kedenring from Utah State and her students will talk about all of the invasive plants. Of course, we have to have a conversation about bioaccumulation of mercury and biomagnification in Great Salt Lake. Kara, the student who was holding the book in the last slide, she will talk about her work at the tar seeps with a lot of students from Westminster. And then we'll talk about astrobiology and how Great Salt Lake connects to Mars, which is really fun. We didn't want to do these. We wanted to make these accessible to students and to anybody who, you know, didn't need to study all of the fine points of every single of 16 chapters. And so we kind of group them by topics that will happen from tonight until February 11th. And note that the brine shrimp harvesters, I'm pointing at you right now because you never did get back to me on if you were going to be able to meet on February 11th. So I just put it in there. I hope you can make it on February 11th. Okay, so that's it. I mean, really now, I mean, if you're just joining us, I'll recap logistics. I hope that you brought Great Salt Lake themed food or drinks. I would love you to type those into the chat box right now so we can vote on your favorites. If you have any comments as we're going, we're gonna type your questions in the chat box. You can upvote them, and then at the end, we'll have a question and answer period where we will answer those live on this webinar. And then again, these are gonna be posted online. So you can watch these later, send them around to your friends, and have all of your students, you can assign your students to read these. That's so mean, assign them. So our first person today, Dr. Sarah Null, is an associate professor of watershed sciences at Utah State University. She has a PhD and master's degree in geography from UC Davis and a bachelor's degree in international economics from UCLA. Her expertise is environmental water management using systems modeling, mathematical modeling, and field studies. Recent research includes improving aquatic habitat objectives in water resource systems models, and evaluating trade-offs between human and environmental water uses with uncertainty. Sarah has long loved saline lakes. I love that you've loved saline lakes forever. She pursued graduate school after working many summers as a naturalist at Mono Lake in California. Recent Great Salt Lake research includes modeling salt balance between the north and south arms, using a water balance to estimate lake level without human water demands, estimating costs of water conservation and water markets to provide environmental flows to the lake, and assessing water uses and infrastructure that threaten lake ecosystems. Null also works in other saline lake systems, including the Walker Basin in Nevada, Urmia Lake in Iran. And when not working, Sarah loves skiing, eating tacos, traveling, and spending time with her family. So join us, Sarah, and I will shut up and you can take over.
Great. Thank you, Jaimi. This is really fun. I'm excited to be here. So I'm going to start by sharing my screen and make sure that we can all see that. And that's not the right slide. Let's get on the beginning. Can everyone see that? Nods, at least by the panelists. Okay,
yeah,
good.
I can see it.
Okay, thank you. So yes, I have a little bit of a love affair with saline lakes. And when I first interviewed at Utah State University, that was the first thing I thought was, oh, great Salt Lake is out there. So that'll be a nice reason for me to continue working on Great Salt Lakes. So today I'm going to be talking about water development, consumptive water uses, and the Great Salt Lake. And this is a chapter for the book that I did with Weenwort Spa. Okay, so starting with lake elevation, Great Salt Lake reached its lowest elevation in 2016. And so this plot on the left is showing time on the x-axis and lake elevation meters on the y-axis. And this is a weighted mean elevation for both the north and south arms. So we put it all together to get a total lake elevation. So 2016 was the lowest. We've had a couple ties for the wettest years, 1986, and then in the late 1800s. And then looking over here at the map at the right, especially at the lake over here, this blue portion of the lake is at its lowest extent. So that's the lowest area when in 2016. And then this kind of sandy color is the highest water extent. So you can see in 2016, the bays were dry. The lake was about half of its area. And so there were really big changes. And so our first question was, why is Great Salt Lake so low? What's going on? Is this from climate variability? Is this water demands? What's really happening here? And then the next thing I'm going to talk about in this talk today is what happened to the water that once used to reach the Great Salt Lake. So we're going to talk a little bit about consumptive water uses. So that means water that people use that do not come back to the lake. So it could be things like plant evapotranspiration. It could be water demands for cities or industry. It could be wetland plants. All of those we would say are consumptive water uses. Talk a little bit about water development and some effects on the biology. And then we're going to talk about potential solutions to stabilize Great Salt Lake level and biology. So the first thing we did, and this goes back to a previous paper that Wayne first authored. And so the first thing we did was look at stream flows through time. And so this figure here is showing actual observed stream flows in Blacksmith Fork in black, and the Bear River flows that were reconstructed from tree ring estimates. And so so those are estimates, and you can see that the two correlate very well together. And they're, but overall, another thing that I'd like you to notice is, one, there's a lot of variability, but that trend line is not going down. So what we can say from this is, from the past, we wouldn't expect Great Salt Lake to have declined if precipitation and stream flow have not declined. So this isn't talking about the future climate change. This is only looking at the past. So then we looked at people. What sort of water are people using? So these plots here on the left have, again, time on the left axis. The bottom plot is showing lake elevation, and the top plot is showing water use. So let's start with the top plot. This is showing water use through time. And so you could see that from the time that Utah was pioneered, there was a lot of agriculture, and that started using more and more water. Again, and we're talking about consumptive water uses, so not necessarily, flood irrigation where some of that water eventually might make its way back to the Great Salt Lake or back to rivers. But over time, starting in about the 1900s, we see other water uses really start to pop up. So for example, we see urban or municipal water uses, wetland uses, solar ponds, all of those are using water. So then we used the water balance, and this was led, this was led again by Wayne Wurtzbach. And so we took the observed lake level of Great Salt Lake, and that's here in red on the bottom line. And then we modeled what would happen if we didn't have all of these consumptive water uses. And from that, we got this green line. And again, you could see that there's natural variability. We would expect that in terminal lakes, which integrate climate and water use, but there's really no trend line. There's no, the lake hasn't just been dropping over the last few decades. So this told us, okay, the Great Salt Lake level is declining, and consumptive water uses are really the culprit. So who uses the water? And I already gave you a good hint to this in the last figure. This is showing it in another way, but really all of us. So agriculture uses the most right now, but urban and industrial uses use a good portion. Mineral extraction uses a good portion. Wetlands and reservoir evaporation is a little bit less. But interestingly, in the future, we would expect urban and industrial uses to start using a greater percentage of that water, and probably agricultural water uses to drop off, as usually as water becomes more scarce, some water is moved over from the agricultural sector to the urban sector. So that's a change we would anticipate in the future. So along with consumptive water uses that have increased over the past century, or a little bit over a century, we have built a good deal of water infrastructure in Utah. And so the map on the right is showing major reservoirs, whether they're colored by federal, private, and state ownership. The plot on the right is showing time on the left axis, reservoir capacity on the y-axis, and that's showing this ever increasing reservoir capacity that mostly ended after 1985, although the future of that is in question, and I'll talk about that a bit more later. And then one more thing on this map that I'd like to point out is right here along the Wasatch Front, most of these valleys used to be agricultural, and right now we expect the population of Utah to double by about 2016. And so we would expect these urban areas that are primarily along the Wasatch Front to the water demands to keep increasing there. So one of the solutions, or one of the proposed solutions to meet that demand, is a new reservoir on the Bear River, or in the Bear River watershed. This goes back to the Bear River Development Act in 1999 that stipulates that 220,000 acre feet of surface water should be developed. This kind of map, kind of pictures on the right, is showing it's over a map, if you can kind of see that. And these are pictures of the 6 shortlisted locations where a dam could be built now. Some of them are up in the mountains, like right down here along Temple Fork. Some of them are off-site storage, like this one right in here in Whites Valley. And some of them, this one right here, would butt up right against Willard Bay. So there's a huge variability in where these proposed reservoirs might be located. The estimated cost is $1.5 billion. That, by the way, is lower than other similar dams that have been proposed in California and some other places. So, so that cost is certainly an estimate. And then modeling suggests that if 220,000 acre feet of surface water were developed, it would reduce Great Salt Lake by another 5.5 feet. And again, that's vertical feet. It's not distance on land. That's 5.5 vertical feet, and this is a shallow lake, so that would look like a very long way on the surface of the land. So yesterday, or 2 weeks ago, I was giving a talk about humans and impacts of water diversions on Great Salt Lake levels. And my last two bullets here got smushed together. And so I want to go over this and correct it. It's always really hard to pull back misinformation once it gets out there, and I never want to be the person to do it. So I was talking about the Bear River Development Act, It was passed in 1999 to develop 220,000 acre-feet of surface water. If a new reservoir is built, it's estimated to cost maybe about $1.5 billion. And here's the important part where I made a mistake. If that reservoir is built, we anticipate that Great Salt Lake's level will drop by about 8.5 inches. And 2 weeks ago, I smushed it with this lower bullet saying that if all the water in the whole compact was developed, then we would expect Great Salt Lake level to decline by about 5.5 feet. And those are all modeling estimates, and I kind of gave my talk and got going on autopilot, and I didn't even realize until the next day. And so this is my correction for that mistake. And now the next point I want to make is that Utahns use a lot of water. So this figure on the left is from our chapter, and this is showing Utah over here, the cubic meters per person per year that Utahns used, and this is compared to other Mediterranean and semi-arid locations. And so you can see that Utah's really an outlier, right? We use quite a bit of water. And then if there's people in the audience thinking, well, I don't really think about the water use of Israel and Spain and Italy, but maybe you know other states quite well. This map on the right is showing water use by state. And so the colors are showing current water use. Utah's actually has the second highest per capita water use if you look at public water supplies. So it's in this really high, Idaho is the first, it's in this very high area of per person water demand. And then these percentages are the changes that are estimated in the future. So one of the things that I did with Eric Edwards was we wanted to think about how much it would cost if we weren't to build a reservoir, but instead really target water conservation. So anytime, as a person who studies environmental water management, anytime I see places with very high per person water use, I usually think water conservation is the cheapest way to spread our water farther. There's usually very low hanging fruit there. So we wanted to say, okay, if we wanted to allocate more water to Great Salt Lake, so we started by saying, what if we stipulated that we are going to allocate 20% more streamflow to Great Salt Lake, and we made water users cut back on their water. So we made them conserve water. What would be the cost of that? And so in this plot in here, we're looking at these numbers here, 20% increase to Great Salt Lake, and this is looking at costs of water conservation. And we found that just by stipulating 20% cutback of water for everyone would cost one-time cost of about $37.4 million. So you can see right there, it's a much cheaper alternative. But that's not really the end of this, I would say, solution or strategy, because some of you guys might have heard of cap and trade type of solutions. Like we use them a lot for air pollution. So we wanted to say, what if we apply cap and trade to water conservation? So that's saying some people that could conserve more easily could conserve more than 20% and sell their water, and other people that maybe it's hard for them to conserve could purchase that water, so they wouldn't have to conserve at all. And so that's what we mean when this says interbasin trading and interbasin trading. That means you could trade water within a specific watershed, the Bear, the Weber, or the Jordan watershed, or you could trade water throughout the whole Wasatch Front. And the larger area, as soon as we have interbasin trading, that's where we get really these cheapest costs associated. Really, that would make it easier for people too, because again, people or industries or cities that can conserve most easily would do that and be able to sell some of their water. So overall, we found that this could cost anywhere, conservation could cost anywhere between $14 million to $96 million. You could see these different bars here, depending on how it's really done, whether we stipulate water conservation or whether we allow a lot of flexibility with water marketing. So then another thing that Wayne and I did for this chapter is we wanted to look at other saline lakes and think about what are other saline lakes doing to restore their systems. We're not the only saline lake that has had water levels drop in, over the past many decades. So we looked at a couple different alternatives. This isn't necessarily meant to be all inclusive, but to give us an idea of what other places are doing. So some places like Mona Lake, that's where I got interested in saline lakes, the lawsuits were really used to sue water users, to sue the city of LA and bring some water back to Mona Lake. Places like Walker Lake in Nevada are doing environmental water purchases. So this is most often implemented by nonprofits. And so nonprofits purchase water and then they dedicate it to in-stream uses. Sometimes there's interbasin water transfers. This is very common in Jordan and Israel and Palestine. These, though, more recent research has shown that these appear to be band-aids. They appear to be solutions that might help in the near term, but in the longer term, they don't necessarily change behaviors of water uses. Some places are diking lakes to basically make them smaller. So they're saying we're never going to restore this whole lake, but what we can do is dike it and make it a smaller lake where we can maintain some ecosystems and some ecosystem functions. And then finally, there's some places that really are just mitigating problems now. And so Owens Lake and Salton Sea, both in California, are places where they're not necessarily trying to restore the lake as it was, but they're trying to maybe stop dust and stop some species from dying. Now, one more thing that we realized when we were doing this is it's always cheaper to preserve saline lakes at the outset than it is to restore them later. And this, I don't think, is unique to saline lakes. I would say this is how restoration goes. But to give you a couple examples, at Owens Lake, which I just talked about, so far mitigating only for airborne dust has cost over $1 billion, and the costs are estimated to exceed $3.6 billion over the next 25 years. So those costs vastly outweigh the value of that water in the first place. So saline lakes are very valuable. And then water purchases at Walker Lake have cost about $57 million as of 2016. So again, significant cost to try to restore these systems. And now I know I've talked a lot about water demands, consumptive water uses, some about economics, a little bit about economics. And so for those of you guys who are going, hey, I'm really interested in the biology, why aren't we talking about that more? Remember that lake level affects the biology. And so here I have a portion of the relationships between Great Salt Lake level and some biological parameters. This is from data from Forestry, Fire, and State Lands, which made really a nice kind of stoplight, green, yellow, blue, of where are healthy lake levels and where are not healthy lake levels. And I've represented a few of them here. So in this figure, green is desirable lake levels for things like South Arm salinity, brine shrimp, grebes, phytoplankton and bay habitats, bacteria diversity, white pelicans for Jaimi, and island land bridges, wetlands, and dust. And so you could see that there's really not, very straightforward solutions. These are complex problems that we're dealing with. But we do know that when all of these different biological parameters get really low, they all are threatened. And with that, I'm happy to, probably questions will come at the end. So here is the contact information for Wayne and for I. And then I think probably I turn this back over to Jaimi in the next talks and wait for the panel at the end.
And can I just have a clarification really quick, Sarah? And we do have a couple of questions, but somebody asked, did you really mean to say the population would double by 2016, or was that taken out of context?
The population is supposed to double by 2060.
2060.
And that's 2060, yeah. So maybe there's a misunderstanding. 2060.
Thank you.
Yeah.
Ooh, you finished right in time. There's your alarm right there. I'm even alarming. I'm gonna get you. Um, well, now I'd like to switch and start to think about climate change in Great Salt Lake. And I have to throw like so much kudos to Dr. Bonnie Baxter. Not only is she my work wife, I mean, really, if like you think about a partnership that um, that you have with your spouse. That's how Bonnie and I work together. I think sometimes we spend more time together than with our spouses, and I think that twice as much stuff gets done like working with us together rather than working apart because we have different superpowers. So I feel really lucky to work with Bonnie and be her work wife. Dr. Bonnie Baxter has spent more than 2 decades studying the microorganisms of Great Salt Lake, where salinity is the primary driver of microbial diversity. Her surveys of the lake's microbiota reveal secrets to life in salt saturation and impacts of dilution in this system. Her specific areas of interest include DNA damage and repair in halophilic archaea, microbialite biodiversity, and the preservation of halophilic microorganisms and their molecules over geologic time. The latter has intriguing astrobiology implications regarding biosignatures that may remain on Mars from past salty life. She co-founded Great Salt Lake Institute at Westminster College to facilitate research on the lake and provide outreach opportunities for science education. Bonnie will be here with us, hopefully for most of these, but really, we're really excited to hear about climate change today.
That's super. Thank you, Jaimi. I think that you as my work wife has been brilliant, but this year we took a husband, which you can do that. It's a very Utah thing. So now we became sister wives, and David. David Parrott has brought some immense energy to Great Salt Lake Institute, and we're really excited. I want to give a quick shout out. I was looking through all of the people who joined us, and of those I recognize, Oren is here. He studies halophilic microorganisms in the Dead Sea. So he's here from Jerusalem, and it's about 3:30 a.m. in Jerusalem. And Mike Dial-Smith is here from Australia. He's from the eastern side of Australia. So I think it's about noon 30 in Australia right now. So Aaron is winning extra kudos for getting up early, although I'm pretty sure he doesn't sleep. But I think if I were to calculate in miles, forgive me, Aaron, I think you're about 7,000 miles away, and Mike Dial-Smith is about 8,500 miles away. So Mike wins the furthest away participant for the evening. Just saying. Plus he's here like before it actually happened. He's here like earlier. So that kind of counts for something. First of all, I just want to say that oolitic sand is a thing at Great Salt Lake. And if you want to fight me, I think I have the best Great Salt Lake meal, which is Israeli couscous in honor of Aaron. Which look a lot like oolitic sand. And I dare you to tell me which is the couscous and which is the oolitic sand. Okay. I'm not actually eating right now because I have to talk to you. Okay, so I'm going to talk about climate change in Great Salt Lake. And when we started thinking about this book, about framing it around this time, and a time of change is what we said. We were thinking climate change. And then I started paying more attention to the work that Sarah Null was doing and Wayne Wurzbaugh. And as we were writing this, we realized that the first chapter had to be about water diversions, because that has set us up for, frankly, failure with respect to climate change. We're not in a good situation. So this is the second chapter of the book. Climate change comes after water diversions, and I will explain why. So I think this is a really critical time. And we can look to other lakes and think about why. If you look at lakes like Lake Urmia in Iran, you can see over the last bit of time that this lake has become completely desiccated, practically desiccated. If you look at the Aral Sea, you can see the same story. And if you ask what happened, the story is always the same. There's some water diversions that occurred. In the case of the Aral Sea, for example, I think 9 nations share the watershed. So that's a lot of coordination. We can't even coordinate with Wyoming here in the US. Utah can't coordinate with Wyoming, much less, 9 nations. And there's an ecosystem response that is negative, and in most cases, this severely impacts the migratory bird population. But the impacts on humans that have been documented on saline lakes that are shrinking are pretty nasty. There are dust storms, there are diseases, and there are increases in water costs. So what hasn't happened yet is we haven't really seen the impacts of climate change yet, but we've set ourselves up for failure. So that's kind of the framework I wanted to take as I'm talking to you about Great Salt Lake. So on our planet, here we are. Here is Great Salt Lake, and it's in a basin that is called the Bonneville Basin, which is named for the last large lake in this area, which was during the Ice Age, the last Ice Age, the Pleistocene. And you can see the salt playa all around. You can see the Bonneville salt flats to the left of Great Salt Lake. You can see the railroad causeway across Great Salt Lake that creates a hypersaline lake on the north part that has turned pink from all of our halophilic archaea and bacteria that live there and make these beautiful colors. And you can see the south arm, which is closer to the city. If you look at this blue outline, that is the Pleistocene Lake Bonneville that was held in during the Ice Age with ice dams. And then as we went through the Pleistocene to Holocene transition, the Holocene is the epoch that we're in now, we end up with Great Salt Lake, which I see as kind of the puddle in the bottom of the bathtub. But this orange portion, this actually is the current modern day watershed. So the modern day watershed is one of the largest in North America, and it's about probably more than 75% of Utah's population. I've seen as much as 83% of people in Utah are in this particular watershed. And of course it is shrinking, and Sarah set this up really nicely. So you understand that most of the reasons it's shrinking have to do with consumptive uses and agriculture. We also have a lake that's very segmented. On the left is this railroad causeway that is splitting the lake in two. And on the right is a sample of some of the salt ponds that are around. So there's some damming with respect to mineral extraction. And that just prevents water flow. That messes with the water, and that needs to be in our mind, that we don't have a lake that is naturally formed. We have a lake that's been intervened by humans. The other thing that's interesting about Great Salt Lake is that it's very shallow. So if you look at other terminal lakes in the region, in the Western United States, you'll see that they're rather deep. And Great Salt Lake is shallow, and this means that a lot of its surface area is exposed to the air, so the evaporation rate can be very high. There's some things going on in this area of the world. There are mega drought predictions. That's actually a climate phrase. Climate scientists are calling the southwestern United States a site for a mega drought. That is predicted from hydrogeologic studies, paleohydrogeologic studies from the last millennia and into current data points. So we're predicting a mega drought the Southwest is certainly seeing that. California is burning. The entire Western United States was burning this year. We're certainly see the onset of that. So there's that. And this in part is a change in a different type of precipitation. In Utah, we're kind of used to snow and getting a lot of we live in an arid climate until the winter comes, and then we get a lot of snow, and folks love to ski here. But there's going to be a shift. These are the predictions. There's going to be a shift in the type of precipitation that we see, and that's going to matter. If we get rain instead of snow, that will matter. There's going to be a change in the quantity of precipitation. Temperature increases are, of course, predicted by global warming. And then a shrinking Great Salt Lake will create dust. And this starts to create a negative feedback loop that I want to talk about. So that impacts our local air quality, but it also impacts the reflectivity of snow, which means it will melt at the wrong time. And that turns out to be really important. So the dust and the temperature increases will impact this mistiming of snow. And then the water will rush in great volumes too quickly and will evaporate to the air versus recharging the ground aquifers, which is what needs to happen in order to fill Great Salt Lake. So I tried to piece together a little model with my mad skills today. So here's what I came up with. So we have mountains full of snow, and that snowpack is where we get our water for Great Salt Lake, for drinking, for everything. That's where we get our water from here. And there is albedo, or reflectivity, with respect to the snow. So the sun shines on it and it reflects away mostly. And this allows the snow to melt slowly, and we get a trickle that over time will recharge the groundwater and will lead to an ample Great Salt Lake. The alternative is we have dust that lands on the snow and creates less reflectivity. So we get less reflection off of there, more absorption, which means it gets warmer and it melts more quickly. That, with increased temperature with respect to climate change that we anticipate, leads to the snow melting more quickly and at the wrong time. And so if you get more snow melting more quickly, you get a larger runoff at a given time, and you don't recharge. Instead, you evaporate that water. And if you evaporate that water, you don't recharge the groundwater, and then you get a shrunken Great Salt Lake. So I'm not a water scientist, that's Sarah Null, but that is my rudimentary understanding of the way the system works. And the bad part of this is that it's really a negative feedback loop. So at the top, you see this Great Salt Lake is shrinking, and you have exposed shorelines. So then that increases the amount of dust, and that decreases the albedo, the reflectivity. And so you have a mistiming of snow melt. And then you have a lack of groundwater recharge. And that means that Great Salt Lake shrinks more. And then you continue this cycle, and it gets worse. And it will be amplified by greater temperatures from climate change, by less precipitation as an impact of climate change. This is going to accelerate this feedback loop. So this is the fear that we have, is that we've set ourselves up for failure. So a few words about how this might impact the biology of this ecosystem. So Great Salt Lake biology is a pretty simple food web from the viewpoint of ecologists. There are microorganisms that feed the invertebrates of the lake, and then those invertebrates feed 10 million birds. 338 bird species depend on Great Salt Lake. So that's kind of the simple version of the food web, and I've left humans out of here because Carla's going to talk later about humans. So let's see how climate change will impact each of these compartments of the food web. So microorganisms will be impacted, and this is a picture of microbialites at Great Salt Lake. So microbialite is the parent term for things like stromatolites. Microbialite, and we use the parent term because there's all kinds of different structures at Great Salt Lake. These are rocks that are created by microbes. So microbial, and "ite" is the word that is the suffix that geologists use to make something a rock. These are rocks created by microorganisms. They're actually super cool. They're loaded with microbial mats that do photosynthesis, and these guys bring energy to the entire system. We are currently working on a project where we're measuring that. We're measuring the amount of photosynthesis that occurs in these microbialites versus in the open water. And it's just phenomenal how different it is. So microorganisms will be impacted. We've done some work on these structures in the North Arm, and they're completely dead. When we look at them in this less saline, more productive South Arm, they're very active. And so we know salinity can impact these structures. So less water to the system means more saline. And it means these microorganisms are going to not be able to do their function. So who eats the microorganisms? The invertebrates. So of course, if salinity increases causes failure in the microbial communities, then these invertebrates will be impacted. And that could mean that there's just different invertebrates at different places, or that one type of invertebrate, say, I absolutely love a magnified version of a brine fly larva. So that's what I have at the top here, because they're really super creepy and kids love to look at these. They're really frightening. But those guys aren't going to handle the lake becoming too salty. And if brine flies aren't here, that's the reason a whole lot of birds are here. That's one of the reasons. So we could be endangering this entire species by the lake getting too salty. The other thing that can happen is you can create compartments where, for example, these brine shrimp are in a little pool that is less salty, and carixids, these water boatmen here, are eating them. So you can change predation dynamics, and this could be bad for the brine shrimp population if there's a segment of the lake that becomes less saline because of groundwater feeding and segmentation. So birds will be impacted. If these invertebrates change, obviously the food for the birds is changed. Also, the bird habitat is changed in a couple of really important ways that I will show you. One is affecting their feeding grounds, and one is creating land bridges. So birds are, I didn't know this until I read the shorebird chapter in our book as an editor. And it turns out that shorebirds are uniquely designed for the water depth that they feed in. And so shout out to Heidi and Ella and John. I know at least Heidi's here. I saw her name on the list. You guys did a great job on this chapter. And what I know is, as the water depth changes, as the lake shrinks, the invertebrate population changes. Yes, that community changes, but also the birds have to feed somewhere else because they can only feed at a certain level of water based on their leg length, and their leg length is not something they can change, right? The other thing is land bridges. So there is a really important population of American white pelicans that lives on Gunnison Island in the North Arm of Great Salt Lake, where there are no fish. And this population flies like 100 miles a day to get food for their babies, instead of teaching them to feed in the water like most white pelican populations do. So it's a really important population, and it's in terms of breeding populations, it's the second largest in the world. And Jaimi has, along with the Division of Wildlife Resources, set up cameras out on this island to catch their dance parties, which is what you're seeing here. So they have this really amazing backstory. So what happens if these pelicans and their friends, these herons that have been nesting there for hundreds of years, what happens if these amazing bird populations in their rookeries, in their breeding grounds, are impacted by dried up land around the island? What happens is that predators get in there, and that's what our cameras are showing. So if you can see on the right, there's a coyote who has entered the population. He's staring down a baby heron, and you see the gulls all around are disturbed by his presence. So we have now documented coyotes on this island, which probably weren't there before. So it changes the entire ecology of the lake and on this island, land bridges being produced by climate change and water diversions. So I also want to note that humans will be impacted. We get lots of ecosystem services from this lake, including like it costs us less to dispose of our waste because we don't have to clean our sewage as much because it goes into a salt lake where there is no fish. That's a weird one that you wouldn't anticipate, but this ecosystem gives us a lot of benefits. There are other economic services, for example, the brine shrimp industry and the mineral extraction industry. Our next speaker will talk about how humans have been impacted by Great Salt Lake and how humans have impacted the lake. And she's a sociologist, so I will let her speak to that. This is really a critical time, and I don't want to leave you with just depressing thoughts. I want to tell you that there is action, and that many of us here tonight are involved in some of that action. There are some models and strategies. There is a current model, a Great Salt Lake integrated model that the Great Salt Lake Advisory Council commissioned from Jacobs Engineering, and it looks at the next 10 years and plots different scenarios and tries to sort of bring home, let's take all the conditions that we see in the state of the lake right now. Let's look at the climate, let's look at the diversion scenario, let's look at water use, and let's model some outcomes. And Jeff Denblinker with Jacobs is really eloquent about speaking to this. He did a lot of great work putting this together. They talk about 4 different scenarios. One is a baseline scenario where we really just continue the way we're moving. The other is this state water strategy that the governor of Utah has proposed and that we hope to work towards. The next one is adaptive innovation, where we come up with really creative water solutions. And the last one is hot growth, so serious population increases and more pressure on the water, and we're not doing enough to really anticipate that. So what happens in those 4 different scenarios? So again, this is looking over a 10-year period from now to 2030. And that baseline strategy, you can see on the right, we would lose 3.3 feet of elevation at Great Salt Lake if we just keep doing what we're doing. And 3.3 feet to a very shallow lake is a big deal. If we look at that state water strategy, then we can reduce that to 1.9. If we do some really creative adaptive innovation, we can reduce that to 1.2. We're still losing 1.2 feet, but we're not losing 3.3 feet. If we do nothing and we have this hot growth that we're anticipating, this population growth in Utah, we can go down 11.7 feet in the next 10 years. I can't tell you how much dust that will create. That is terrifying. So this is the scenario we're in. In this model, we cannot compute a scenario that is in the positive. So when people say, are you sure Great Salt Lake's not going to flood again? I'm like, well, the data suggests that that's not in the cards, right? So the Great Salt Lake Advisory Council, which is an advisory board based on, there are members from local government entities, from industry, from nonprofits, et cetera. And it's been a really wonderful advisory board to have. There's no funding behind it. but they do work on problems with respect to Great Salt Lake and come up with solutions. And they just recently came up with a 12-pronged plan that really has the potential to increase water coming to the lake. They researched water strategies that have worked in other Western states. And they're hoping that these will be guidelines to people who manage the lake and create strategies to incentivize even all of us, our water users, and what we can do. Another couple things to mention is the state of Utah in 2019 funded a position called the Great Salt Lake Coordinator within Forestry, Fire, and State Lands. So our state, the lake bed is state lands, and so it falls under Forestry and Fire and State Lands. And there's a comprehensive management plan that is legislation that is managed by this division. And this Great Salt Lake Coordinator position, Laura Vernon is now holding that position, and she's on the call tonight. So if we have any questions for her, she is really excited to answer them. And thank you for being here, Laura. Also in 2019, there's a concurrent resolution from the House to address declining water levels of Great Salt Lake. And so this was just a statement from our legislature to say, we recognize that Great Salt Lake needs water flowing to it. And it created a group of stakeholders that will give, at the end of this year, will give recommendations that hopefully feed into next year's legislature in March. So again, it comes with no money and no mandate, but at least the legislature has acknowledged that it is important to get water to Great Salt Lake. What some of us would like to see, or maybe some water rights associated with that, or some funding behind that. So hopefully something happens next year in the Utah legislature. And with that, I leave you with the notion that this lake is a special place, and we need to do all that we can to keep water flowing to the lake.
Thank you, Bonnie. You went over 15 minutes though.
Damn
it. Now, we would like to welcome Dr. Carla Koons Trentelman. She's an environmental and natural resource sociologist who has taught at Weber State University for over 10 years. Her research interests focus on natural resources and the environment, particularly issues related to the Great Salt Lake and water. She teaches environmental and natural resource sociology and occasionally sociology of water. Dr. Trentelman completed her PhD in sociology at Utah State University in 2009. For fun, Carla enjoys hanging out with her husband, Charlie. I know Charlie's on this also. He had bison for dinner, I saw, or a bison burger for dinner. She loves hanging out with her husband, Charlie, their sons, and their families, including her 4 amazing grands. Her interests include birding, especially at the Bear River Migratory Bird Refuge and other areas around Great Salt Lake. And I have to say that Carla sends me a lot of students that work on the Pelican project and help me analyze all of those dancing pelicans. So welcome, thank you for being here, and take it away.
Thank you, thank you. So I'm gonna just pull up my PowerPoint. Okay, so I'm a sociologist, so the thing that interests me scientifically is the relationships between humans and Great Salt Lake. And it turns out that our relationships have always been about change and adaptation. Humans have changed the lake has changed humans. And then forces external to both the lake and humans have brought changes to both, whether because of climate and weather, or technology, economic forces, other things that have forced both humans, that have affected both humans and the lake that they live near. But the fact that both sides adapt doesn't mean that things are okay. Some key recurring themes of change and need for adaptation have included things like the elevation and related size of the lake, and importantly, humans' attempts to manage that. Human development, both in population and in the growth of communities, and technology, some related to the lake and attempts to manage the lake, some related to broader trends, for example, transportation. Humans have interacted with Great Salt Lake in varying ways through all of these different things, at times feeling fonder and at times not so much. So I just wanted to give you a little bit of a feel for how folks tend to feel about the lake. This is one of those things where a lot of folks who are connected to the lake think that most people in Utah don't really like the lake or care about the lake, or that they love it or hate it. And so that was actually what I did my research on originally. And I focused on the neighbors of the lake because they're actually more vulnerable to changes in the lake than other folks. They get to experience both the positives and the negative aspects of the lake up close and personal. So in research that I conducted a while back, I found that Great Salt Lake held a number of different meanings for these lake neighbors. And these are the kinds of things that I saw in response to an open-ended survey question. These different meanings emerged. And we can see a vast majority of these folks felt pretty positively about the lake. In both quantitative and qualitative work, I found a good number of folks felt very appreciative of Great Salt Lake. They felt a positive sense of place. They felt attached to the lake and its environments. They were drawn to the beauty, to natural aspects, recreational aspects of the lake, also social aspects, whether that was because of family history or cultural meaning, or a place for neighborhood connections. Many of these folks found the lake's uniqueness something that was really cool about it for a number of different reasons. On the flip side, some folks had a very negative sense of the lake. It meant negative things to them. But as you can see, it was this pretty small percentage of these folks. And then for some folks, even folks who live very close to the lake, they really had no sense of the lake at all. It really didn't matter to them. It didn't mean anything to them. Now, over the years since the European settlement, a good number of things have affected the relationships between humans and Great Salt Lake. And I need to just do a shout out to Wayne Wurtzbaugh because I stole a lot of his slides for my presentation tonight. Thanks, Wayne. So technology, including transportation for transportation of goods and people, is one of those things that definitely affected the relationship between humans and lakes and Great Salt Lake. So first of all, trains brought the causeway, and we definitely are familiar with the story of the changes that to the lake that the causeway has brought, that the railroad causeway brought. But also trains brought lots of people to the lakeside resorts that were on the east and south end of the lake. And for a really long time, the trains actually helped folks develop a relationship with aspects of the lake that they saw as unique and positive, and it was a really cool thing. But then as we continued developing as folks and cars became more popular and more folks had them, cars started taking folks away. And so folks would do mountain excursions instead of lake excursions and those sorts of things. But then eventually cars brought folks back to the lake, and especially to Antelope Island with the causeway to the island, and also to some of the beaches. But then the technology that's been used to manage the lake, as well as other kinds of things have ended up leading to what many have referred as Great Salt Lake's 5 separate lakes that have very different saline systems, very different, require different management. And so this whole thing is about that relationship between people and the lake and what people's interactions have done to the lake itself, to the ecosystem. Another important part of the relationship between people and the lake is the economics. I know many of you are very familiar with the economic study that was conducted in 2012. Mineral extraction, the brine shrimp harvest, Great Salt Lake recreation, and other economic services, some of which Bonnie alluded to earlier. All of those things that are provided by Great Salt Lake and its ecosystem bring in $1.32 billion per year. $1.32 billion per year. And that includes $375 million in labor income, with 7,700 full and part-time jobs annually. Now, Laura Alt is another one of those folks like us who works a whole lot with the lake. And I love the thing that she says about this, that Great Salt Lake is the goose that lays golden eggs. You just have to feed it water and you get all this gold. Now, importantly, all of these things are affected by changes, large changes in elevation, whether those changes are high or low, to higher elevations or lower elevations. So that becomes a very important part. Now you've heard, the other two folks have already talked about Great Salt Lake elevation, but I'm going to mention it as well. Historically, the elevation of the lake has drawn folks closer and then chased them away, right? So at its historical average or common elevation of 4,200 feet above sea level, the lake is 75 miles long and 28 miles wide and covers 1,700 square miles. Now let that sink in, okay? That's a pretty great lake. We don't necessarily think about those numbers real often, okay? Now, the low lake levels left those resorts, left a bunch of resorts high and dry, including during the prior historic low of 1963. And this slide refers back to what we for a long time have referred to as the historic low. And that historic low, or that lake elevation, was at 4191, so 4,191 feet above sea level. At that elevation, the lake covered only 950 square miles. Okay, so two things about that. Only a 9-foot difference in lake elevation meant 750 square miles of less coverage. Okay, so when Bonnie was talking about, you know, how much decline that was going to be in lake elevation, and when Sarah was talking about keep that in mind, only 9 feet of difference meant 750 square miles less coverage. Okay, and also there's only a 9-foot difference between the average elevation and the historic low. So that becomes a really important thing to keep in mind. I also want to point out, so this is that historic low, and then this is the flooding that I'll talk about in just a second, the historic high. Because we're talking sociologically here, I want you to think about what that means if you live close to the lake. If you live here, right? So at one point you get flooded, at the other point, the lake is way the heck out here, right? So that's one of the things we have to think about when we start thinking about these elevation differences and what that ends up meaning, okay? Now in 1986 to 87, as you already heard, we hit our historic high for the lake at 4211.85. which covered 2,300 square miles, well over twice the land covered in 1963. Now, humans have attempted to manage the lake elevation during those highest elevation levels. In 1982, the Utah State Legislature passed a bill mandating that Great Salt Lake be managed at an elevation below 4,202. Well, that didn't work out so well, right? So from 1982 to 1986, the lake rose 12 feet to its historic high of 4,212, causing over $240 million in damages. So we built pumps for $60 million. And of course, by the time they were ready, the lake was already beginning to decrease naturally. It did help lower the lake level faster, so it wasn't like it was a total waste of money or anything. But I think that that's an important point for us to keep in mind, that when we were being threatened, we responded to the tune of $60 million. Now the issue is reversed, right? And you've already heard about this. A key aspect of our current mutual relationships is that for the last 15 years, Great Salt Lake has been low, coming close to that historic low and meeting it several times within just the last 5 years, let alone the last 15 years. Now, meanwhile, on the human side of the impacts, and you heard a little bit about this already as well, you may have heard that the population of Utah is on the increase, okay? So between 2000 and 2010, Utah added more than 500,000 folks, which was a nearly 24% rise at that point in time. The population is projected to double between 2015 and 2065. This matters for the lake in two ways, okay? First of all, because those folks need a place to live. And in Weber and Davis counties, most of the area that's left to build is west, ever closer to the lake. So, for example, Syracuse in Davis County is that what used to be a fairly little town, just right off of the causeway to Antelope Island. Syracuse grew from 9,000 in 2001 to 30,400 in 2018. So that's the kind of development that we're seeing. This kind of development can encroach on wetlands. It is encroaching on uplands that protect those wetlands. So there's that. But then additionally, like you've already heard, it's that many more folks who need water. And you heard about those issues in the last two presentations. So that brings me up to challenges for the future for the lake and for us. My single biggest concern here, you've heard us all hint at it, but I'm going to say it out loud a little bit more loudly perhaps. My single biggest concern here is that Great Salt Lake's elevation is already low and has been for the last decade and a half, even setting this new historic level, as you heard. It's already there. And we know that diversions of Great Salt Lake's water sources are responsible for substantial portions of that decline. The lake is already experiencing these reductions now, before there's any additional rise in population, before there's any additional urbanization of the areas closest to the lake or further development of lake-bound water, right? In 2016, 48% of the lake bed was dry and exposed. And you've heard these lake scientists argue that the lake's ecosystem can't afford any further impact on their elevation. You know, you heard Bonnie's concerns about that. And yet, climate change, all right, which will not only affect Great Salt Lake's sources of water, it will also affect humans sources of water, further exacerbating these tensions over water, right? And you've already heard that this increasingly low lake level is problematic in many ways. You've heard Bonnie talk about how it's problematic for the ecosystem. It's also problematic for Utah's economy because it affects the brine shrimp industry, the mineral extraction industry, and the recreation that, that the lake can support. Those things are all, you know, really challenged as the lake continues to decline. And then perhaps the biggest human issue, which Bonnie also raised, is the increased risk for air quality problems for lake dust, with increasing potential for health consequences. The more of the lake bed that's exposed, the more lake dust blows around, and air currents bring much of that into the Weber County Ogden airshed, where I happen to live, and where my husband, who has asthma, happens to live. So there are definitely some consequences for us all from all of this. But fortunately, there are causes for hope. And I'm going to try and step this up so there's a little time for questions here. So I definitely need to say out loud that yes, conserving water individually, privately, in our homes, in our yards, all of those things. Of course, we need to do that. It's good and helpful, and we should be doing that, but we have to remember that that is not enough, not by far. That's a micro solution to a macro problem. We have to also be focusing on the macro. But here, like Bonnie was sharing with you already, there is some good news. So state and local policymakers and politicians are definitely interested in focusing on these issues with the kinds of legislation that Bonnie has already talked to you about. The thing I want to just really emphasize about this, though, is that this requires some really heavy lifting. These folks who are running these bills and working towards these policy changes really need our support. So we need to be doing our homework on these bills, and we need to be supporting the kinds of progress that we're making. The biggest lift with this stuff is related to Western water law. And for a really long time, as soon as you would say that, everyone was like, okay, well, there's nothing we can do about that, right? But what's very cool is that it is being worked on. We see work being done on that as well, including really important work on water banking, which is complex stuff that requires a whole lot of different steps, but which thus far has found legislative support. So we've got to be able to lend our support to those legislators. Now, I'm going to also argue, just mention that another place we can make a big difference is by growing more lake lovers. I have to include this slide because it's got my grands in it. And also it's a big shout out to Jaimi and Bonnie's book, The Great Great Salt Lake Monster Mystery, which is a fun book to use with your kids. But one of the things that my research showed is that if we can get kids connected to the lake, when they grow up, they are awesome protectors of this ecosystem. So we need to keep doing that. One thing that I find really interesting is that while humans attempted to manage Great Salt Lake during its crises for humans of the high elevation years, even spending $60 million to build the West Desert Pumping Project, thus far, we've never attempted to manage problematically low elevations with that same kind of effort, with, you know, an all hands on deck kind of effort. Of course, with high elevations, we could focus on fixing the lake, but with low, we need to focus on humans, on our own practices. I would argue that it's time to shift our own focus. So with that, I'll say thanks. And I think I probably went over too. Sorry about that, Jaimi.
That's okay, I'll forgive you. Hey, well, I really want to know if I really wanted to practice my polling, but I would love panelists to turn your cameras on. And I think the most important question that we can ask, and it really goes along with what Carla just talked about, what do the rest of you think? What can we do as normal Utahns to directly support our Great Salt Lake environment? Do other panelists have some thoughts on that?
Laura's unmuting. You go, girl.
Well, I wish I had a silver bullet or a magic wand that you could all wave to get attention to the lake. But I think kind of what Carla alluded to now was just the growing support for the lake, or growing lake lovers. I think that's happening. It's been happening over the last couple of years. You know, just in the last 2 months, the Great Salt Lake Advisory Council has put out or sponsored some reports that have been put out in the news. So we've got some attention to the fact that the lake is drying up. And just to give you a real personal example, they did a press release, I think, and then it was on Channel 4 or Channel 13, and they did a little spiel on it, and my mom saw it, and my mom said, my mother, who I talk to all the time, said, I had no idea that the lake was in this sort of predicament. And I've talked to several people since then, and I think that's just been in the last 2 months that I think we're gaining support more and more as people are starting to pay attention. But it's up to me now and other people, like Bonnie was saying, all these people doing this fantastic work on the lake, to get the science, to get the policy changes out there and make a difference. So kind of rambling, but I think people are paying attention, and I think the more people that are paying attention is going to direct the focus from lawmakers, from management agencies, and shift their focus. So,
and I think having someone like you, Laura, as this Great Salt Lake coordinator position, it's a fabulous new effort. And you see all the different agencies, and there's been this saying that Great Salt Lake is dying by 1,000 cuts because the management was in so many different compartments. And so I think having this position is really an opportunity to pull some of that together. And you also reach out to academics like us, and I'm hopeful with that, in that respect.
Yeah, well, it's the work that you guys are doing that is leading to the changes that need to be made, that I can take to policymakers and get out to the public that says, look, this is the evidence behind the fact that we need to do something. So just figuring out how to get that message out, how to say it,
I think
where it sticks.
I think some of the recent legislation, while it's a bit of lip service, I think it's really promising. When I moved here, and certainly decades prior to that, people thought of Great Salt Lake as where the waste goes, where the water that we can't use goes. And so just the mind shift that's happening from this is a place where the waste goes to this is a place we want to protect is really large. And so we need to build on that and get some teeth in there, but that's a big mind shift that's happening.
I agree.
Can I ask you some questions about water? We have, a couple of really great questions. Preston, he wants to know what proportion of water inflow to Great Salt Lake is direct precipitation versus flow from surface streams versus groundwater, and is all of the water leaving through Great Salt Lake through evaporation? And I'd like to add some Meg Wolf. She's actually one of our students, and she's asking kind of a similar question about, is Great Salt Lake controlled by groundwater recharge or stream flow? And are there any studies that associate when melt rate increases how Great Salt Lake responds?
Wait, Meg was a former student who's currently teaching for us, so thank you, Meg.
Oh yeah, that's right. Thank you, Meg.
That's a great question.
So I'll take the water balance portion. The direct precipitation, this is off the top of my head, but it's about 30 or 31% of the water to the lake. Then the most of the rest is through streamflow contributions. Direct groundwater is about 3%. That number might be a little bit misleading because groundwater can also come up in the stream contributions prior to reaching Great Salt Lake. But the direct groundwater to Great Salt Lake is very minimal, about 3%. I don't remember the rest of the question.
Are there any studies that you know of that associate when melt rate increases and how Great Salt Lake responds? So Meg is interested because in these relationships and working on this for her research and would love to pick brains.
Oh, go ahead. Other people would
Well,
be better at that.
I don't have a great answer to that. I just know that two researchers have done a lot of work, most recently on the snow melt, and it's Greg Carling at BYU and Skiles, University of Utah, Professor Skiles, her first name is escaping me, but they look at the albedo effect that that Bonnie was talking about and snow melt, but I haven't seen that related to groundwater. So, Mackenzie Skiles, yes, thank you. Sounds like she already knows about Dr. Skiles' work. So,
we have some questions about changing water rights. So Lynn wants to know, I heard that changing the water right rules to eliminate beneficial use provision will really help to maintain the lake level. Can you comment on that? And I guess on top of that, Dave Richards kind of commented back that the Utah Division of Water Quality has designated Great Salt Lake its own beneficial use protection class, divided into those 5 subclasses that include wildlife for protection of a quality sufficient for waterfowl, shorebirds, and other water-oriented wildlife. Does anybody have comments on the beneficial use?
Beneficial uses, it's almost hard to not be a beneficial use. You have to more prove that you're not, at least in the West. So I'm not concerned that Great Salt Lake wouldn't be a beneficial use. The problem is that Great Salt Lake doesn't have any dedicated water.
So that water rights issue is a big deal. And for those of you who aren't from the Western United States, that's something I never heard of when I grew up back east. And certainly in other countries, you don't have the same thing, but water rights are kind of a Western US ordeal. And water rights, it's sort of governed by laws from the 1800s that the public has right to the water, but if there's an intervening water right, then people can have a water right that allows them to take certain water upstream from the other water. And Great Salt Lake being at the bottom and not being considered useful because it wasn't drinking water or water you could fish in, doesn't have a water right. And so the question at hand is, should it have a water right? And if so, how do you do that?
And it's not necessarily only upstream and downstream. Here in the West, not all, but a large proportion of our water rights are based on time. So there's senior water right holders and junior water right holders. And that's one concern, is that I talked a lot about conservation, and if you implement conservation and water then just goes to the next more junior water right holder, it doesn't solve anything for places like Great Salt Lake. So there has to be mechanisms in place to get water to places like Great Salt Lake.
And this is why the tackling the Western water law is such a heavy lift, because this is in the West, whiskey's for drinking, water's for fighting.
Can I ask you another question, Sarah? This is from Katie Newbern. She's with Friends of Great Salt Lake, and we do want to shout out to all of the organizations. I mean, and thank you, Wayne. Wayne actually commented on that, and we do want to recognize all of the organizations that have been working on getting Great Salt Lake into making Great Salt Lake lovers out of everybody. But Kay wants to know, when you were discussing the cost for increased water allocation to Great Salt Lake, what was included in those costs? Increased prices for water users?
When I guess I'm a little bit confused. When I was talking about the conservation, it was the costs of really implementing that, like requiring water users to conserve water. And so there was some prices for that. Water buying and selling, there can be prices, you know, per acre foot of water. It tends to be different sometimes for agriculture versus urban, because urban water users and agriculture water users use water differently. They might demand it in different times or in different quantities. I'm not sure if I answered that question, because I'm not sure I totally understood it.
Katie, if we didn't answer, you know, please type in the comments again. We'll answer a couple more.
Yeah.
Can I just jump in really quick, Jaimi?
Oh yeah, of course, please do.
Actually, when you ask the question about what can folks do, one thing that I would absolutely say to dovetail on what Wayne was saying is keeping track of what Friends of Great Salt Lake tracks through the legislative session from January through March is such a good way to keep track of what's happening with the legislative session, with what the discussions are, what kinds of bills you should be supporting, or telling your legislator, no, don't vote for that, or whatever. You know, that Friends does an awesome job of keeping us abreast of what those issues are. So I just wanted to say that out loud, because it can feel overwhelming with, well, how do I keep track of this stuff?
Even to us, because I think we're, you know, I've talked to Lynn about this, we're knee deep in our research projects and working with students and teaching, and we don't do advocacy. That's what Friends of Great Salt Lake does. And so we're really enamored by them. And Ann Neville's on this call from the Nature Conservancy. So we're excited about Fremont Island, Ann. That's wonderful. So there are many. Go ahead, Jaimi.
Well, and other groups too. Great Salt Lake Audubon does a really great job. If you're one of their members, they do a really great job. And then a lot of these organizations are working together. Steve Erickson is always keeping us up to date on what's going on the Hill, and being part of any of those organizations can help you stay informed and what to call your, I mean, not what name to call your legislator, but maybe what you might want to tell them if you call them. I mean, not that I'm biased. Can I ask you, Carla, a question? This is from Wally Gwynn. And Wally Gwynn, I'm so glad that you're here. I'm so excited to see you on this call. Wally has spent his life doing research on Great Salt Lake, and has really spearheaded outreach about all aspects of the lake through his work at the Utah Geological Survey when he was there. He wants to ask, is industrial use of the lake of concern to those who live around it?
Not really. Because the areas where people can actually live close to the lake aren't very close to where the industry is. So where folks primarily live on the lake are in Davis County and Weber County in the very western area. And I guess there are some folks who live kind of sort of relatively close to Compass Minerals and some of their stuff off of 12th Street. But for the most part, because of the folks who live out there, and the culture, they're pretty conservative folks, and so they're pretty supportive of industry. They're pretty supportive of business. Some of them have family members who have worked in the lake. One of the things, I can like go off here, so I'll try and keep it brief. But one of the things that was really interesting to me when I was conducting my research is that there are a lot of folks still who live very close to the lake in Davis County and western Weber County, whose families have owned that property since the Mormon pioneers came, right? And they've been on that same property. So they have very deep familial connections to that land. And because of that, they have all kinds of stories about how their family survived because of grandpa being a duck hunter during the Depression, or because they went out and helped their uncles like dig salt off of the exposed lake bed during the Depression, that then they took into 25th Street and would bag up on 25th Street and sell off the back of the truck, kind of thing, and all kinds of really fun stories like that. And so I think because of those connections, and because they're conservative and in favor of industry and business and those sorts of things, that there isn't concern about the lake industry. There's mostly support about lake industry.
What about MAGCOR? When I worked with the brine shrimpers, we were really worried about MAGCOR. I mean, there were times when we would go into nearby and our mucous membranes would burn, and we would cough and we would have to get off the lake. Is MAGCOR maybe a separate? Did you hear much about MAGCOR? Or yeah.
Again, because of where MAGCOR is located, on that very south, almost southwest part, nobody lives close enough to have that really affect them much. The population of Tooele County would be more, like even the inland population of Tooele County would be more affected by those kinds of things. And there are books about that. Chip Ward wrote a book about that very thing, in fact. But the folks who live closest to the lake in Davis County and Weber County are far enough away from that they weren't getting those kinds of consequences. But that's a really good question.
Well, and if I could fill in the gaps on that, the company is now called U.S. Magnesium Corporation. But in prior years, they had the highest air quality pollution quotient in the United States, and one of the highest in the world based on chlorine gas. They produce magnesium chloride, and that is it cleaned up now. It's filtered now, so they no longer have that claim to fame. But I think Jaimi was breathing it during that time.
Yeah, that would have been exactly during that time.
Yeah, but I do have to say that I've been really impressed over the years with folks from the brine shrimp industry and from the mineral extraction industries and their participation on so many committees and so forth governing lake health, and their care and concern about the lake, I think, has been pretty tremendous. And so I do want to shout out to the industry folks that I know Wally has worked with a lot of them, and I've been very pleased to have good relationships with those folks as well.
And Wally, I just have to say, I grinned ear to ear when I saw your name in the list of the attendees, because your book was one of the things that I cited. It was one of the few places where I could find any Great Salt Lake social science was in your wonderful book, Wally. So thanks for being here.
Yep.
I know we're going over time. Panelists, do you want me to stop or do you want to keep going? It's up to you. I can keep going.
My husband said you should stop.
Well, Don doesn't matter, whatever.
I'm not seeing any complaints from my husband in the chat, so.
Okay, I haven't seen anything. Are you okay, Sarah? I'll ask you the first one. So we know that, this is from Krishna. We know the estimation of Great Salt Lake levels and sensitivity analysis is a very challenging undertaking due to lake complexity and multiple sources of uncertainties. And so for these lake levels estimations, water demand and estimation is one of the critical components. Are there any tests or sensitivity analysis that you do so that you know how precise those numbers you're citing are? Like, we're going to lose 11 feet of lake level change, that kind of.
Yeah, that's a great question. So I almost always do sensitivity analyses in my work. In this specific case, like the trends from consumptive water use are definitely downward. So we could say they're 10 feet, we could say they're 12 feet. That's going to capture the uncertainty there, but the trend is very, very clear. And when uncertainty analysis becomes really important is when the trend isn't clear. So for example, for precipitation with climate change, we don't, you know, like some climate models say we're going to get wetter, some say it's going to. Analysis is really important. In this case, you know, we could have put, and we probably should have put uncertainty bounds on that 11 feet projection from consumptive water uses, but the trend is very, very clear there.
I'm having a hard time knowing what more other questions. There's so many good questions to ask. This is also from Krishna Darbani. You presented on climate change and implications to the lake briefly. Could you elaborate on if there are any research findings that indicate which climatic parameters are changing exactly and how their degree of changes would likely have implication to the lake levels?
So I did a lot of reading because this isn't my field. I'm actually a molecular biologist. But we really wanted to start the book off with a chapter on climate change. And as I said, we preempted that by asking Sarah to write a water diversion chapter with Wayne. But I read a lot about climate change in the Southwest, and I had to really be a student for a while to understand this. And Jaimi and I would talk it over and try to discern all the different models. And so there are a couple of really good studies from folks at Cornell and NASA on the mega drought of the Southwest. So the Southwestern region is really well documented, and there have been some amazing studies. There's some really interesting parameters around Great Salt Lake that aren't necessarily taken into account. For instance, the Wasatch Mountain Range. So mountainous areas have a really different sort of local climate. There are some really, really good studies on the changing of surface temperatures in the oceans and the patterns of those and how those patterns are changing and how they're predictable. They're really great soil hydrology studies that are very predictive. So we can take all of those things and say, in this region, these are the predictions. But my understanding is locally we have features that could change that. So climate change predictions, for instance, for the northeastern US are heavier rain, more hurricanes, more stuff coming in off the Atlantic Ocean, and we're seeing that already. Climate change for the Southwest is more drought, less water. And when you do have water, it would be, more likely to be rain than snow. Those are generalizations. And when we're talking about a system where we have the water being fed from a giant mountain range, then there's some things that are unpredictable. So I think in this chapter, we tried to kind of bullet the lessons we've learned, and then sort of like Sarah's talking about the uncertainty, to highlight that the places we don't know we're going, but the trends are not looking good. So I guess that's my answer to the question. The things that we know and the things we don't yet know.
So please take note, I decided to just not run our poll today because we were having such a wonderful conversation, and I didn't want to interrupt it with who had a bison burger or who was drinking rosé from the North Arm. That would be Mara Hannenberger. All of you, I'm going to contact you and we'll get you some silly prizes, like maybe a Great Salt Lake book, a Great Salt Lake Monster mystery book. We have these really awesome little brine shrimp ornaments that are made by our friends at Bowerbird, really cute little magnets. And we also have some signed books, Wild Birds of the American Wetlands by Rosalie Winard, that's one of our dear friends at Great Salt Lake Institute. But I almost forgot to ask you some questions from Chris Klein, and she actually just said she had to leave, but I think they're really great questions about these nuances of Great Salt Lake and water. So some people say, hey, I need to flush my toilet. We should be flushing our toilets more, and we should be taking longer showers, and we should be actually irrigating rather than like drip irrigating because it recharges the groundwater. And so does anybody have kind of thoughts on some of those issues, those nuances that we could think about?
I'll start with that, and other people can chime in as they'd like to. So some of what you've brought up are good concerns, that not all water is used, and that's exactly the reason that we use consumptive water uses when we look at changes to Great Salt Lake. So we want to know not how much water is taken or diverted in any given place, but how much is used and will never return. And so that's really shaped a lot of the direction that we have gone with the research. Sometimes there are really, from an academic perspective, really interesting feedbacks in terms of trying to reduce water use in terms of when you look at diversions, for example. So sometimes people look at changing, sprinklers from flood irrigation to drip irrigation. And on paper, you should say, yes, that will save water. The problem is that water can go to more junior water rights holders, and it doesn't always get to places like the Great Salt Lake. And so there's really complex and interesting questions about, not questions, but pathways about how water moves through the environment. But as a short answer, that's why we looked at consumptive water uses. And other people can jump in now.
I guess I would just say that the Great Salt Lake Advisory Council just sponsored a study. It's called the Conservation Impact Study, that looks at reuse as one of the reuse of water as one of the impacts to water getting to Great Salt Lake. And it's an issue that in that research they decided needs closer examination. So this coming year, we'll be looking at water reuse, which isn't necessarily, I guess, not encouraging you to flush your toilet more, but if we do recycle water upstream, how does that water get stuck upstream and never makes it to the lake, versus if you do flush your toilet 4 or 5 times. So stay tuned. We're doing some more research on that in the coming year.
One of the complexities about this ecosystem is, so here at Weber State, we really pride ourselves on pushing the envelope in terms of sustainability, and we've been wrestling with that very question in terms of water sustainability on campus. Like, to what degree is it helpful to the ecosystem, and to what degree is it harmful to Great Salt Lake if we do this practice or that practice or another practice? And so we're going to be watching that research, and let me know when that's available, because I'm on our water council for Weber State, and we're all scratching our heads about that very thing, given our location with the lake.
I want to be able to answer that question when people ask me, because I get it all the time and I just don't have a solid answer right now. So I hope to have one soon.
One more interesting point I noticed, this person, I forgot their name, sorry, Jaimi, asked about indoor water uses, and we all were educated really, really well to reduce our indoor water uses, like turning off the faucet when we brush our teeth and taking shorter showers, and you know, sometimes like if it's yellow, let it mellow, those sorts of things. But most of the water that we use is for outdoor water uses, and that's something that somehow escapes that public education, where the indoor water uses really, really hit us hard, but that's not where we use the bulk of our water.
Interesting. How does lake effect affect our snowpack? Does anybody want to take that one on?
I can tell you from work on the Great Salt Lake Comprehensive Management Plan that it was found that up about 8%, 8 to 10% of the snow in the Wasatch comes from lake effect snow. So you would have that much less with, I mean, decreasingly less with decreasingly lower lake levels.
I hope I'm not just shutting things down too quickly, but does anybody have any, you know, we've gone almost a half an hour over. So for our next Salty Science series, I'll plan for 2 hours so that we can vote on cool Great Salt Lake themed meals in between and take a potty break. I guess we all learn as we're going along. Does anybody, you know, have any final thoughts that they want to get out in the airwaves?
I just want to say shout out to Jaimi. Thank you for all the organizing. You've done an amazing job.
Cheers.
Thank you. I just want to say that I just feel, you know, I've been working on the lake for 20 years, and I agree with the panelists before that talked about really this like momentum and inertia that the lake is starting to make in our, you know, in our psyche, in our minds. It's not just stinky and buggy. There's these important parts of it, and it's still stinky and buggy, but it has these other important components for wildlife and for humans. And I'm just really excited to be part of this kind of tapestry of people that are working together to inform us and to make policies and to manage wildlife and to do research. And so I guess that's what I would like to say. So thank you, everybody. The next panel will be on December 3rd. You can register at greatsaltlakeinstitute.org, or hopefully I've already registered most of you that asked me to just register you all. So yeah, thank you so much. We'll see you on December 3rd. We hope everybody stays healthy, and the lake is a really great place to go to be outside right now. Thank you.
Thanks, guys.
Sarah, check out my cup.
I wanted to bring up the public trust doctrine a number of times tonight, but I never did.
Yeah.
I was also like Carla. Oh, sorry. One more thing. I had a couple slides about the water banking legislation, and then I took them out thinking I would go over, and then you talked about it, and I was like, oh, you talked about it better than I. So that it was great.
It was well played.
I kept it very, very short because I don't know how to talk about it, but I know it's important.